So today's going to be a review day for both Chapter 5 and 6 because we do, of course, have a Chapter 5 and 6 quiz coming up tomorrow. So let's get started. So we're going to have some mixed review of Chapter 5 and 6 today in preparation for that quiz tomorrow. Remember, Chapter 5 was about trigonometric graphs and Chapter 6 was about trigonometric identities. Now, not only do we have a quiz this week, we also have a unit exam on Friday that's going to cover Chapters 4, 5, and 6. And yeah, I know I've kind of overwhelmed you this week. It's kind of a lot. But again, it's all review. We finished everything about mid last week. So we don't have any new information today. We just have to make sure we're summarizing what we've already learned. Now, just so you know, today's plan is going to be kind of like one we had before, where I'm going to show you some questions. I want you to pause, give them a try on a piece of loose leaf, and then I'll show you how to go over them, right? So there'll be a lot of pausing and a lot of trying a question today. That's what I want you to be focusing on for today. So Wednesday's focus, of course, though, we're going to be focusing on reviewing Chapter 4 on Wednesday because it has been a few weeks since we've looked at that. But don't worry about that quite yet. We're just focusing on Chapter 5 and 6 for now. So first question here, create an equation in the form that models the following graph. Assume the scale on the y-axis is 1. So in other words, we're saying that this is 1, 2, 3, -1, -2, -3, -4, -5, right? I want you to pause the video here. I want you to give this one a try on your own, and then I'll go over it in a second. All right, so now I'll go over this one. How I like going about these questions is first I like to figure out my midline. Now your midline forms the D part of your formula here, so it would be this piece right here. And how I find the midline is I take the average of the maximum and the minimum. Well, the average here is 2, the minimum is -4, so 2 plus -4 is -2, and then you take that and divide it by 2, so that gives us a midline of -1. So -1 is our D value here. The next thing I do is after I have the midline, I find my amplitude. And the amplitude is basically just how far above or below the midline that you end up going. Since our midline is -1, we can see that we're going 1, 2, 3 above the midline. So in other words, my amplitude A is going to be 3. Now the question itself tells us we have to make a trig function using sine. I want to remind you that sine, as long as it was positive, starts at your midline going up. Well, notice when x is 0, you are actually on that midline, and it is in fact going up. So in other words, because sine usually starts at midline going up, and in this case it is, that tells us we don't actually have a c value here, so c would be 0. The last thing we need to find here is b, and b is often one of the harder ones to find. B is related to the period of the function. Remember, the period of the function is how long it takes to complete one full cycle. Well, notice from a midline going up, the next time we have a midline going up is right here, and that occurs at x is equal to pi. So in other words, we can say that our period is pi, and remember that period is equal to 2 pi divided by b. Generally speaking, we always assume that we're dealing with radians. In this case, it's a very easy assumption because there's constant references to pi. But even if this was a word problem, we'd want to stick with radians as much as possible, unless it explicitly said go with degrees. So anyway, since we know our period is pi, we can say pi is equal to 2 pi divided by b. You can times by b on both sides and then divide by pi. Long story short, though, you're going to find that b is 2. We now have everything we need to know. Remember, there was no c. I explained that before, so we might as well throw this all together. Y is equal to 3 sine. B is 2, and then x, and then plus d, so in other words, -1. That right there would be our equation of this function in the form that it wanted us to give it in. All right, question 2, a word problem. The depth of the water in a harbor is 8 meters at high tide and 2 meters at low tide. The time from high tide to low tide is 5 hours. Create a trigonometric function h of t, where t is the time elapsed in hours and h is the height of the water in meters. Assume that the initial tide is high tide. Pause the video here, give this one a try on your own, and I'll go over it in a second. And now we'll go over it. So again, kind of like the last one, even though we weren't actually given a picture here, I like starting with my maximum and my minimum to find my midline. Well, we know our max is 8 and our minimum is 2. So the midline, or the d value here, is your max plus your min divided by 2. So it's just the average of your max and your min. Well, that's going to tell us that d in this case is going to be 5. So our midline here is going to be 5 meters. Once you have your midline, you can then find your amplitude. And remember, amplitude is how far above or below you go. So in other words, amplitude in this case, since starting at a midline of 5, it's going to go up to 8 or down to 2. Either way you look at it, amplitude is going to be 3. The next thing I see is the time from high tide to low tide is 5 hours. If you think about this in terms of a picture, and again, we're assuming at a high, or assuming we're starting at a high tide, so it's going to go high tide, low tide, and then high tide, and so on. Notice from high tide to low tide, that's 5 hours. That means a full period isn't 5 hours, but a full period is rather 10 hours, because a full period takes you from where you started back to where you were again, right? So in other words, 10 hours is our period, so period is 10. And since the period is 10, we could say 10 is equal to 2 pi divided by b. So times by b on both sides, and then divide by 10. You're going to find that b is actually going to be pi over 5. And it's pretty usual, actually, to have a really weird b value like this. And I know you might be tempted to use degrees instead, but generally speaking, of course, just for whatever reason, in math, we prefer to stick with radians wherever possible. And this one didn't say use radians or degrees, so we should be sticking with radians in this one. So this would be a better b value. The last thing we need here is, because we have an a, a b, and a d, we should need a c value, but this is where you get to be a little bit creative. It didn't tell us what trig function we had to use. It didn't say we had to use sine or cos, so we have a choice as to which one we want to use. Since the tide is starting at high tide, you could take advantage of the fact that cosine usually also starts at its maximum. So if you use cosine in this case, which I'll highly recommend you do, you don't even have to bother with a c value. C values are, in my opinion, the hardest part to figure out in all these. Bottom line is we can make our function h of t is going to equal a, which is 3. We'll use cosine, so we start at our max. B is pi over 5. T, which is our x in this case, t is just going to stay there. There's no c value, so there's nothing else to put in there. And then plus d, so plus 5. That would probably be the most concise answer for this question. Moving on. Question 3. A tire with a nail caught in the tread is a diameter of 60 centimeters and rotates once every 5 seconds. Assume the nail is at the bottom of the tire at time 0. Determine an equation to represent the height h in centimeters of the nail as a function of time t in seconds in the form ht equals a sine b t minus c plus d. Notice in this question, they're actually mandating that we use sine. We can't use cos, whether or not that was going to be useful in this case. We have to use sine in this one. So pause the video here, give this one a try, make sure you come up with a sine equation for this. All right, now I'll go over it. So first things first on this one, we gotta think a little bit logically on this one. Notice it's a tire with a diameter of 60 centimeters. Generally speaking, we can reasonably assume that the tire is going to be rolling on the ground. So our maximum in terms of our height of our nail is going to be the 60 centimeters. It'll be 60 centimeters off the ground at its maximum, and its minimum will be 0, because again, hopefully it's actually rolling on the ground, so our minimum height would be 0. Because of this, we can actually figure the average of these two to find the d value. D is therefore going to equal 30. And coincidentally, actually, your a value, which again can be found after you have your midline, it's how much higher or below you're going from your midline. Either way, though, your amplitude in this case is actually also going to be 30. So that was kind of an interesting situation there. The next thing we could find is your b value, which remember is related to the period. Now notice we see that the tire rotates once every 5 seconds. So that's a full rotation. So that is the period, right? So we can say the period is 5, which should equal 2 pi over your b value. So since it's 2 pi over your b value times by b divided by 5, you're going to find that b is going to equal 2 pi over 5, which I know how clunky that looks, but that's like honestly how we usually would represent this. So b is going to be 2 pi over 5. So we have d, we have a, we have b. We just need c. And this is where we have to take advantage of the idea that we're using sine here. Now, we've been told in the question we have to assume the nail is at the bottom of the tire at time 0. Now, personally, I like drawing myself just a little sketch so I can see what's going on. Since it's starting at the bottom, we can assume that the sine wave that's going to form here is going to look something like this, right? Now, because we're using sine to represent this, keep in mind that sine, as long as it was positive in terms of the a value, sine usually starts at its midline going up, right? So since it usually starts there, we can tell by looking at our graph here that this has actually been shifted from its usual position to the right, right? So in other words, if there was no c value, you would have your midline going up right on your y-axis. But because we see in our little sketch here that it clearly isn't, we must have moved this right. Now we need to think about how far right we're moving it, right? Because we're moving it however much this x distance is right here. This is where you have to take advantage of what you know about the period. The period of the function, we were told, was 5 seconds. So in other words, it went from the bottom of the tire to the top of the tire and then back down to the bottom of the tire after 5 seconds. Now, knowing what we know about a wave, the middle point between a bottom and another bottom is actually going to be a top. So in other words, we can say that the top height occurs after 2.5 seconds, because that would be half, of course, of 5. Now my little blip here isn't probably fully accurate because that was kind of skewed on this one, but between your maximum point and your minimum point, that's going to be where you have your midline going up. So in other words, if we wanted to find our midline going up, it's going to be the middle point between 0 and 2.5, which if you do a little bit of math there is 1.25. Bottom line is, in order to get this function, as long as it was sine, we would have had to move this function to the right by 1.25 units. Okay, so in other words, we would know that our C value is 1.25. Now, before I finish this off, you might be asking yourself, well, hey, since it starts at the bottom, usually cosine starts at the top. What if we just made it negative cosine? I would totally agree with you. I think using negative cosine in this case, rather than using a C value, would make way more sense. But unfortunately, the question does ask us to use sine. So we didn't really have a choice on that one. But again, because it starts at a minimum, I would have used a negative cosine instead. Anyway, bottom line is, let's just throw all this together. H of t is going to equal A, which we already listed up at the top, is 30. Sine B is 2 pi over 5. T minus C, so T minus 1.25. And again, since it's minus, that means it is moving right. And then plus D, so plus 30. That would be the only answer you could possibly have for this question, unless you interpret it in degrees, which I, again, highly would not recommend doing. Please use radians for these kinds of questions instead of degrees. It's just the way that they're usually generated. And I know usually you think, degrees is easier, but radians is more mathematically honest. It's based around a circle itself. We've been through that. Anyway, moving on. Question 4, this is getting into the chapter 6 questions. Determine the exact value of sine 5 pi over 12. Pause the video here, give this one a try. All right, so I'll go over this one now. This is one of those questions where you have to take advantage of what you know about special triangles. I'm going to go through this one really quick. I don't want to explain it in too great detail, but bottom line is we have a 30, 60, 90 triangle and a 45, 45, 90 triangle. Now, with a 30, 60, 90 triangle, 30 degrees, of course, is pi over 6. 60 is pi over 3. And 45 in this one is pi over 4. Now, we need to take advantage of this because we ultimately want to have an angle of 5 pi over 12. Since this is over 12, I would highly recommend making all of these over 12. So that would be 2 pi over 12. This one would be 4 pi over 12. And this one would be 3 pi over 12. Now think about how you can add or subtract some of these together to get 5 pi over 12. I think it's pretty clear it'd be this one plus this one. So in other words, it's like we're dealing with a 30-degree angle plus a 45-degree angle. Now I'll stick within radians just so we stick with radians. Just remember 30 degrees is pi over 6 and 45 degrees is pi over 4. But the bottom line is here we can say that this is sine pi over 6 plus pi over 4, right? All in one bracket. So it's not sine pi over 6 plus sine pi over 4. It's sine pi over 6 plus pi over 4. This is what we call a sum identity. We can use the identity from our formula sheet to construct another formula that'll help us out here. If we consider this alpha and this one beta, then we can fill in the formula to actually be sine pi over 6 times cosine pi over 4 plus cosine pi over 6 times sine pi over 4. Oops, pi over 4, you know what I mean there. So sine, again, is opposite over hypotenuse. So if we're doing sine of pi over 6, remember the opposite side on a 30, 60, 90 triangle. I'm not even going to label it. It's 1/2. Cosine, it's adjacent over hypotenuse. Didn't even look why I drew the over there. It's adjacent over hypotenuse. I'm not going to fill in the sides on this again. It's root 2 over 2. Hopefully you understand that. We've been through it many times. If you don't, please contact me. Cosine pi over 6 is adjacent over hypotenuse, so that would be root 3. That's a 3. I don't know why I have so much trouble with 3's on this. Root 3 over 2. And then sine pi over 4, kind of the same as cos pi over 4. It's root 2 over 2. Filling this in now, 1 times root 2 is root 2. 2 times 2 is 4. Plus root 3 times root 2 is root 6. 2 times 2 is 4. They have the same denominator. You can write it as one fraction, might as well. Root 2 plus root 6 all over 4. That right there, that's the exact value. So there's our answer. We're done that one. Moving on to the next one. Prove, here we go. Prove the following trigonometric identity. Pause it right here. Give this one a shot. Remember, make the left side equal to the right side without crossing that equal sign. All right, let's go over this one. So again, just a little bit of a disclaimer here. The way I go through this might be different than the way you went through that. It doesn't mean that your answer is any less correct. As long as you were able to show the left side is equal to the right side, you're good to go. If you weren't able to, though, I'll show you the way that I would go about doing this personally, but again, it's all up to you. One of my first rules, other than writing LS and RS, one of my first rules is start on whatever side looks more complicated. So I think, without a doubt, the right-hand side on this one looks a lot more complicated, so I'm going to start there. Now, another rule that we usually start with is turn everything that isn't sine or cosine into something that's sine or cosine. We'll see whether or not that helps us out here. Might as well give it a shot. We'll start with that as our very first step on the left side. So cosecant, of course, is 1 over sine x. And then our bracket, another cosecant, is another 1 over sine x minus sine x. Okay. Next thing we could try is maybe I could double dip this 1 over sine x through the brackets here. See if that helps. That'll become 1 over sine squared x minus, well, 1 over sine x times sine x. It'd be like sine x over sine x, or in other words, just 1. Okay. Now, this is looking pretty suspicious. Something squared, 1 over sine squared, right? We got a squared trig function here and a 1. There's a lot of trig identities on your formula sheet that we call the Pythagorean trig identities that often have to do with something squared and a 1. Now, if you look really carefully on here, on your trig identity sheet, so on your formula sheet, of course, you can see that there's 1, and I'll write it up in the corner here, right up here, just so I can keep track of it. There is 1 that says 1 plus cotangent squared x equals cosecant squared x. Now you might be wondering, why on earth am I pulling that one out of the bag, right? Where am I going with that? Well, just watch this really carefully. 1 over sine squared x is cosecant squared x. Okay, so maybe I'll change it back. Cosecant squared x minus 1. That's what we got right now. Well, look at this identity. Remember, the identities that are on your formula sheet are yours and free to rearrange as you wish. They've already been proven. You don't have to worry about crossing the equal sign. They're yours to play with. If we just minus 1 on both sides, you can see that this becomes cotangent squared x equals cosecant squared x minus 1. Cosecant squared x minus 1 is what we have on the right side of this equation. So I can now replace this whole chunk with cotangent squared x. And why did I do that? Well, look at the left side of the equation. The only thing we had was cotangent squared x. So now I've shown that the left side and the right side are actually identical to each other. So remember, when we finish a proof, we should finish it with LS equals RS and put a box around it to let me know that you're done. And again, if you want to be fancy, you can do a little square thing that you fill in, or you can go even fancier, QED. Never actually looked up what that stands for again. All I remember is it's a Latin phrase that basically just says, as it was demonstrated. Whatever you want to do, though, just as long as you show me that, yep, you finished the proof, so I know that you've actually done the question, right? And if this was a diploma year, they actually require this step. Even if you box your left side and your right side, they do require that you acknowledge in one further step that you do this. We don't have to worry about a diploma this year, of course, but the more you know. All right, last question here. Prove the following trig identity. This one looks like an absolute beefcake. Give it a try. It hopefully won't be as bad as I think you're thinking it is. All right, now I'm going to go over this again. Same disclaimer as before. The way I do this might not be the way that you do this, but let's tackle this. I think without a doubt, for me at least, I think the left side looks a lot more complicated than the right side. Like stuff cubed, we don't even deal with that in trig. What's going on over there? Well, let's deal with it. First step is I would change everything into the sine and cosine, right? So cosine cubed, that's just fine. We don't have to worry about that. But cosecant cubed, that one we should worry about. That's going to be 1 over sine cubed. And tan cubed, that's not sine or cos. As much as that's familiar to us, it's not sine or cos. Let's change it to sine and cos. Remember, tan is the same thing as sine over cosine. So sine cubed over cosine cubed. This is a bunch of stuff being multiplied together. We can consider this cosine cubed over 1. Just write it as one jumbo fraction. Now we can say all this stuff on the top is cosine cubed x times sine cubed x. And then all this stuff on the bottom is sine cubed x cos cubed x. Well, what do you know? Look at the top, cosine cubed x, I can cancel with this one down here. And the other one, sine cubed x, I can cancel with this one over here. So really the left side just simplifies down to 1. Doesn't get much easier than that. That's probably the nicest left side you're ever going to see. We wouldn't have known that first looking at this, but starting to simplify it, it did help it out. Since we just have 1 on the left side, we now have no choice but to jump back to the right side, because you can't get any simpler than that. So let's look at the right side. Maybe something I could do on the right side here is, oh, you know what? I was going to say we could turn everything to sine and cosine, but I think I got something better on my sleeve. Remember on the last slide, I told you guys 1 plus cotangent squared x equals cosecant squared x. Well, you notice how we have like cotangent squared and cosecant squared right here? That's kind of interesting. Well, let's use our identity from our formula sheet here and let's rearrange it. Let's get all the cosecant and cotangents on one side. If I minus cotangent squared x from both sides, I'm left with 1 equals cosecant squared x minus cotangent squared x. Well, wait a second, that's exactly what we have here. Cosecant squared x minus cotangent squared x is equal to 1. That's what we have right here. So I can just go on my right side and just say that equals 1. Well, what do you know? Left side equals the right side. LS equals RS. Boom. We are done, right? You might have done that a different way than I did. That's totally okay. There's many different ways to solutions when you're doing proofs, just as long as you're relying very carefully on the identities that are on your formula sheet. You gotta make sure you're not jumping over the equal sign as you do this. Treat the two sides separately and use the identities on your formula sheet to fill in the blanks. So we're done. So for practice, any of the practice textbook questions from chapter 5 and 6 that I've assigned in the past 2 weeks, you might want to give those a good shot. Contact me directly if anything in this video in particular was still challenging to you today. If there's anything we did that you're like, oh man, I just could not get that, contact me, reach out to me, right? I'll help you out as best I can, okay? I would imagine proofs for a lot of us are probably pretty challenging. Again, I don't know, it's just a shot in the dark. But either way, please contact me if you're struggling. And then just so you know, the chapter 5 and 6 quiz, which is open as of this today, right? Monday, hopefully, is when you're watching this. It is open, but I don't expect you to do it till Tuesday. As long as it's done before the end of Tuesday, that's fine. But just letting you know, it is all written response. Anyway, that's it for this video today. Hopefully that didn't take you too long. I know the video is only 23 minutes, but of course you would have paused. Again, contact me if you have any questions, and best of luck on that quiz tomorrow.